Hey everyone, my name is Haoran Zhao. My final project topic is loan default prediction with Lending Club dataset. The motivation of this project is that Lending Club platform connects borrowers to investors and facilitates the payment of loans. The basic idea is that borrowers apply for a loan on the Lending Club marketplace. Investors can review the loan applications along with risk analysis provided by Lending Club to determine how much of the loan request they are willing to fund. The goal of this project is to plot interactive charts with Plotly and Seaborn in EDA and to classify loans to good and bad ones using machine learning models, including linear quadratic discriminant analysis and neural network with Python API Keras. The overview of this project is I'm going to install the required software, download data from Lending Club website, select features as predictors without look-ahead bias, conduct exploratory data analysis, engineer the features, and then I will feed machine learning models and compare model performance. In terms of the software and technologies that I used Anaconda, Python version is 3.7. I used Jupyter Notebook. The packages that I use includes Keras, Seaborn, Plotly, Matplotlib, Pandas, Scikit-learn, and SMOTE, which is oversampling technology that can deal with this imbalanced dataset. My hardware environment is Windows. I have 16 gigabytes RAM, which is typical. Regarding dataset, I download the dataset from Lending Club website. So if we go to the home page, and if we scroll down to the bottom of this page, we will see the tab called statistics. If we click that and if we go to the download data, on the left hand side it has download loan data. So pretty much I download everything here. And I put the data into a folder, and this is all the data that I downloaded. So in total I have 2.15 gigabytes data. And in terms of software installment, this is Anaconda, and if you go to download, you can see I download this Python version 3.7. Seaborn should be a package that is with Anaconda. You can directly import it, but this is the homepage. It has a lot of beautiful data visualization graphs and samples to show like how they can plot those beautiful charts. Plotly it has its own website as well. Is the cool part of it is very interactive, that you can like change like whatever the way that you want to change. And Keras this is the Keras website. And in terms of Keras, in order to install it, you can go to this installation tab and just follow the instruction. You can just pip install Keras, and that's it. So regarding EDA, so I import the packages I need, and then the first thing that I did is to pre-processing the data. I merged the yearly and quarterly data downloaded from the Lending Club website. So I first merge all the data together. Then I look into the data set. There are 151 columns in the raw data set, which is huge. So in the initial feature selection stage, I apply several very rigorous selection criteria. So the first criteria, I'm saying that the full sample feature coverage should be larger than 60%. Otherwise, there are too many missing values that it is so hard to deal with. Certain portion of the columns are regarding the second application for joint applications. The second applicant for joint application. But the thing is, there are only around 5% of the loans are joint application info sample, which means that 90% of the feature column regarding the second application will be missing. The second criteria is I'm saying that the feature with local height bias should be dropped. One of the column is called post charge-off gross recovery, and that is like with this recovery as its name. So whenever there's a number, there's a numerical number that will indicate the loan has been in charge-off status, and charge-off is essentially a very bad status, and it's a bad loan. But the thing is, as investors, we want to predict if the loan is going to end up as a good loan or bad loan at the initial stage. So the information of this recovery is something that we don't know. So I decided to drop it from the predictors. The third criteria is the redundant features. Like credit grades and credit subgrades contain the same information, but just in different granularity. I kept grades and dropped subgrades. And zip codes and states also contain similar information, and I just choose one of them. So that's the feature selection stage. From this raw data, I just filter down to this DF. That's what I really need. And then I did data cleaning. I dropped rows that are all missing. I changed some row columns in string types, numerical types, and I deal with some very specific column. Then the EDA. So this is a big part. So first, I want to see the distribution of the loans. So I plot the mean loan amount of Lending Club through the years. This is two plots from Seaborn. The x-axis the years, the y-axis is the mean loan amount. As we can see, the Lending Club business is doing like pretty well. The mean loan amount is increasing over the years. Seems like borrowers are relying more on the platform to finance. And in terms of distribution of the loans, it seems like most of the loans are ranging from $5,000 to $20,000, which can make sense because they are personal needs. That sounds about right. The second part is the good loans and bad loans. According to Lending Club website, here's the loan definition. There are several status. One is current, which means the loan is still up to date on all the outstanding payments and is not fully paid yet, so the loan is still live. And also we have in grace period, late 16 to 30 days, late 31 to 120 days. Fully paid is pretty good, and default charge off the bat by parts. So I used Seaborn to plot again. So this is the chart that I got. The left hand side is pie chart. It shows that in full sample I have 12.66% of bad loans. So the majority of them are good loans, which is great. And on the right hand side, I shows the good and bad loans decomposition through the years. The interesting thing is that even though through the years the business is doing well, and also the good loans and bad loans is moving together, if you can see. But the trend starts to deviate in around 2016. The good loans is still going higher or at least stays high, but bad loans are actually going down. And the reason is because there are only two terms of loans, either 6 years or 5 years. The thing is that if the loan is still live, most of the loans within the last 3 years are new loans, so most of them are in current status. But it doesn't mean that the loan will end up with like a good loan. It could default. Just as time goes by, I believe these bad loans will catch up. And this part shows the number of loans by grade. We have one A, B, C, D, E, F, G, and A is the best, G is the worst. And this right hand side is interesting. It seems like the percentage of good loans for A grade is higher, and as we move to the right hand side, the percentage of good loans goes down, which is the blue bar, and the red bar shows the bad loans. This can make sense, and just by plotting those good loans and bad loans by grade, we can see that grade can be a very important feature. the last part I did is the loans by state. I'm wondering, like, what's the default rates by United States? If I classify the loans by the origination state where the applicant like lives, like, can I see anything? So this is the functionality that I use is called Plotly. It is here. Like this is the structure. I gave all those locations, colors, and information. The cool thing is that I can zoom in and zoom out, and if I click this export, it directs me to this website. And another cool thing is that if I say that I think the California default rate should be like, say, 18%, and I change it, and that will reflect it on the chart. Then I can change the labels, I can change the colors. It's quite interesting and quite cool. I think it is going to be very like impressive if we present something to clients. And that's the EDA part. Moving forward, I did the feature engineering. Since we are dealing with financial data set, which is by nature very noisy, feature engineering is especially important. And I have several points. The first, as I have already showed that this sample has some sample bias, because in the recent 3 or 5 years, most of the loans are still in current status. It's still live. So what I did is drop those loans. And then I generate response variables. I define those as the bad loans. And then I deal with missing data. So if it is missing, I just replace those columns with mean value in each loan grade. So it's a group by grade, and then give it a mean value in each grade. And deal with dates. One of the interesting features is called earliest credit line date, which seems to show that how long how long the credit history that applicant has. So we would assume the longer the history of the applicant's credit line, the more confidence we have on his FICO score, and the lower probability of default in general. But the thing is that the date is in absolute term. It shows like what's the first credit card date that he got. But the thing is that we are trying to predict. So we need to anchor that date to the issue date, because that's the information we know at the investment stage. And then I deal with categorical data of variables. There are pretty much 2 methods. One is like give a numerical number like A to B. We maintain an order. That's ordinal order we want to maintain. The other thing is using just one hot encoding, create dummy variables. I also add some polynomial terms. I think that the relationship should be linear because financial world is so complicated. I also generated another feature that I think might be helpful. So the final part is the model part. I import all the models that I think that I need to use. In the data preparation, I sampled a little bit so that I can save some time. And then I train the data, split the data set to train and test data set, standardize it, and this is custom function to plot confusion metrics, as we will see later. One of the technique that I use is called this SMOTE, which is a library to deal with imbalanced data set. The problem is that, say we are dealing with credit card data, the default observation in that credit card data set is going to be very small. So the problem with building a model using that kind of data set is that they will just predict that every observation is good observation, then the accuracy is going to be very high. So oversampling is a technique to deal with this imbalanced data set, so that we can oversample a little bit of the default observations so that the training set can be a little bit balanced. And then we can, pretty much it's a technique to achieve a higher recall and at the cost of a little bit of precision. And we will see later. And it's performing pretty well. It's quite typical in the industry. So first model that I use is called LDA. Just train the model, save the results. And this is the confusion matrix I got. This is right. The X is the predicted label. The Y is the true label. Majority of them I still predict as good loans, and there are some predictions that is I think it is bad loans. So it's kind of working okay. QDA. This is the QDA model. I did not plot the confusion matrix, but it's going to be very similar. Then I use Keras. So I build a 3-layer, fully connected neural network using this sequential. And then I add this input layer, layer 1, 2, 3, and then compile the model. I use 1000 epochs, and batch size is 182. Then I save the results, and then confusion matrix is looking like this. And the last part of my project is to compare the models. So I plot the LDA and QDA training accuracy and test accuracy. As we can see, neural network is doing pretty well, at least in training set. But as we all know, that if training set we can easily achieve 100%, but that could be just due to overfitting. Interestingly, it's not just, that's not the full story. Neural network is also doing well in the test set. So it seems like in terms of prediction accuracy, neural network is doing a pretty good job. But the thing is that as investors, we care about like how many of the bad loans we can predict correctly. And in terms of data scientist term, that is recall rate. And if we focus on the recall, actually LDA is doing better. LDA can predict more of the bad loans in the full sample of the real bad loans. So if I would have to choose among 3 models, I would actually choose LDA. Going back, in terms of conclusions, throughout this project, I learned that Plotly and Seaborn are very powerful graphic tools that can generate lots of beautiful plots that are very important in the business world. LDA, QDA are very quick and powerful machine learning models that could possibly beat even neural network. It has very wide adoption in streaming data clustering analysis, as it is pretty quick because it doesn't need to go through the iterative process as logistic regression does to find optimal values. The last point is, with Keras, we can build very complex neural network within a few minutes. Since Keras has been fully integrated to TensorFlow, we get the best of both worlds. In terms of future work, the first I would say is the financial data set is very noisy by nature, so further feature engineering will be very helpful to build better models. The second point is that there are still many other machine learning models that I can try, like for example logistic regression, training models, random forest, KN, SVM, you name it. And third, I would say that I use a sample of the full data set for the interest of project time, but I could run it on AWS to leverage more stronger infrastructure. And that's it. Thank you.